Ever wondered how your computer manages and organizes all your files and data? Well, the secret lies in something called file system implementation. It's like the unsung hero of your operating system, quietly working behind the scenes to ensure all your data is stored, retrieved, and organized efficiently on physical media, such as hard drives or SSDs. Imagine file system implementation as a well-organized library, where each book represents a file, and the librarian is the file system, managing where each book goes, how it's accessed, and who gets to read it. This process involves a mix of data structures, algorithms, and system-level features to ensure not just efficient but also reliable and secure storage management. From your favorite photos to that important presentation for work, everything is managed by this invisible powerhouse. So buckle up as we dive deep into the fascinating world of file system implementation. First off, let's understand the architecture of a typical file system. It's a structure that involves layers of abstraction, each playing a unique role in managing the complexities of data storage and retrieval. At the top is the logical file system, or LFS. This is the layer that provides the interface for user-level applications to interact with files and directories. It's the one handling system calls like open, close, read, write, and delete. It also manages file operations and access permissions, making sure that the right people have the right access. Then we have the virtual file system, or VFS. Think of it as an abstraction layer that allows the operating system to interact with different file systems in a uniform way. It acts as a bridge between the logical file system and the specific file system implementation. It facilitates the mounting of various file systems and provides a consistent interface for different storage types. Next is the File System Implementation Layer, or FSI. This layer is the nuts and bolts, managing the specific implementation details for a given file system, whether it be ext4, NTFS, FAT, or any other. It's responsible for data storage structures, file allocation methods, and metadata management. It implements data structures for organizing and locating files and directories. And finally, we have the storage devices. This is the physical hardware where data is stored, such as hard drives, SSDs, optical media, or network storage. The file system implementation communicates with the storage devices through device drivers, ensuring that your data gets from point A to point B safely. So to sum up these layers, the logical file system, virtual file system implementation, and storage devices are the main components of a typical file system architecture. They each have a part to play, and they work together to manage the complexities of data storage and retrieval, ensuring that your data is stored efficiently and securely, and is accessible when you need it. Remember, these layers work together to manage the complexities of data storage and retrieval. Now, let's shift our focus to the core components involved in file system implementation. First up, we have file allocation methods. This is all about how space is allocated for files on the disk. Common methods include contiguous allocation, linked allocation, indexed allocation, and bitmap-based allocation. Each of these methods has its own pros and cons, and the choice of method can significantly affect the efficiency and performance of the file system. Next, we delve into directory structures, which manage the organization of files into directories. This component implements operations for creating, deleting, and listing directories and their contents. It also maintains relationships between directories and files, forming a hierarchical tree structure that makes it easy for users and applications to locate and access files. Then we have metadata management, which is about managing information about files and directories. This includes ownership, permissions, timestamps, and file size. Ensuring metadata consistency and updating it as files are created, modified, or deleted is a crucial task of this component. File system journaling is an essential technique to ensure file system consistency. This technique records changes in a log or journal before applying them to the main file system. In the event of system crashes or power failures, the system can recover by replaying the journal, thus avoiding data loss or corruption. Now, let's talk about file system caching. This method improves performance by storing frequently accessed data in memory or cache to reduce disk access times. But this isn't just about hoarding data in memory. It requires meticulous cache management strategies to ensure data consistency and optimal use of memory resources. And finally, we have file system security. This includes access control mechanisms to determine who can access and modify files and directories. These mechanisms implement user and group permissions, and sometimes they incorporate more advanced security features like access control lists or ACLs or encryption. Each of these core components plays a pivotal role in file system implementation. They work together to manage the complexities of data storage and retrieval, ensuring that the file system is efficient, reliable, and secure. So, to recap, file allocation methods decide how space is allocated for files. Directory structures organize files into a navigable hierarchy. Metadata management keeps track of essential information about files and directories. File system journaling helps maintain system consistency, even in the face of crashes or power failures. File system caching boosts performance by reducing disk access times. And file system security ensures that only authorized users can access or modify files and directories. These components collectively ensure efficient, reliable, and secure storage management. You might be wondering, why is file system implementation so important? Well, let's dive into it. File system implementation plays a crucial role in our digital lives, and its importance is often overlooked. It's like the unsung hero of our computers, quietly working in the background to keep things running smoothly. At its core, file system implementation is all about organization. Just like how you organize books on a bookshelf or files in a filing cabinet, a computer system needs to organize its data too. This organization is not just for the sake of neatness, but it's vital for efficient data retrieval. When a system call is made to open a file, the system needs to know exactly where that file is stored. A well-implemented file system can retrieve that file swiftly and efficiently, saving valuable processing time. But it's not just about speed. A robust file system also contributes to system stability. With techniques like file system journaling, the system can recover from crashes or power failures without losing data. This is because changes are recorded in a journal before they're applied to the main file system. In case of a sudden shutdown, the system can replay the journal and restore the file system to a consistent state. And let's not forget about security. In today's world, data security is paramount. File system implementation plays a significant role in maintaining this security. It manages access permissions, determining who can read, write, or delete files. More advanced features like access control lists and encryption provide additional layers of security. File system implementation also enhances performance. Techniques like file system caching store frequently access data in memory, reducing the need for time-consuming disk access. This makes your system faster and more responsive. In essence, file system implementation is the backbone of any operating system. It organizes your data, enhances system performance, ensures stability, and safeguards your information. Without proper file system implementation, managing and retrieving data would be a chaotic and inefficient process. Let's recap what we've learned about file system implementation. At the heart of it all, it's a process that ensures efficient, reliable, and secure management of data storage on physical media. This is achieved through a blend of data structures, algorithms, and system-level features working together. We delved into the architecture of file systems, starting with the logical file system. This top layer provides the interface for user-level applications to interact with files and directories, handling key system calls and managing file operations and access permissions. We then talked about the virtual file system, an abstraction layer that allows the operating system to interact with different file systems in a uniform way. It acts as a bridge between the logical file system and the specific file system implementation, facilitating mounting of various file systems and providing a consistent interface for different storage types. Next, we discussed the file system implementation layer that handles the specific implementation details for a given file system. It's responsible for data storage structures, file allocation methods, and metadata management. And of course, we can't forget about the storage devices themselves. The physical hardware where data is stored, with which the file system implementation communicates through device drivers. We also explored the core components of file system implementation. These include file allocation methods, directory structures, metadata management, file system journaling, file system caching, and file system security. Each plays a critical role in how files are stored, accessed, and managed. File allocation methods determine how space is allocated for files on disk. Directory structures manage the organization of files into directories. Metadata management handles information about files and directories. File system journaling ensures file system consistency by recording changes before applying them to the main file system. File system caching improves performance by storing frequently accessed data in memory. And file system security includes access control mechanisms to determine who can access and modify files and directories. And there you have it, a peek into the fascinating world of file system implementation. Remember, next time you save a file, there's a whole lot of complex processes ensuring it's stored efficiently and securely.